What does a sand dune have to do with understanding the weather? Find out today on Inside OSU. Go Pokes! Woo! So we'll basically have it hover and then pop it up a little bit, have it hover for 10 seconds.
For the last 6 years, Oklahoma State University's Unmanned Systems Research Institute, or USRI, has been working on technology to study the atmosphere and wind profiles at Little Sahara State Park.
What we're looking at doing is this is the dune shape in a really basic form. And there's basically the separation bubble where the atmosphere flows over the dune, and it actually gets a little turbulent right here.
So this is air that's not dune?
Correct, yeah. If this shape had continued in, if it weren't on Earth, let's just say, and we're under a bunch of different, a different physics set, then maybe the dune shape would be just like this. But because of how it kind of moves and collapses right here, there's a lot of change in how the atmosphere flows over it, and that's what we're really looking at and trying to prove and define.
Now think about, trying to figure out what that wind velocity is up several hundred feet in the air. You can't really see it, but a way to have a drone there pulling that data out is really valuable to us.
USRI uses a technology called photogrammetry to stitch together the high-fidelity images captured by the drone and create a digital elevation model.
So this is showing how high certain parts are. So you can see the dune crest right here is a bit higher than the rest of the model. And so this is actually it's like you cut the dune like a cake, and then you're actually just able to see the layers.
Now this is all very useful and very interesting, but the most exciting part's the drone.
Yeah, let's go look at them.
Awesome.
So a couple of them are repeated, like this little guy right here. So we always have some backups that we're bringing. This is actually a Phantom 4 Pro, and we'd use this for a lot of photogrammetry applications. It's kind of a commercial off-the-shelf version, just very reliable and able to take some really great imagery.
Cool. And then we have this big guy in the middle.
Yes. So this guy is actually one that was designed and built completely in-house. And what we did was we added this tilt here. So the sensor on top is one of the anemometers that I was talking about, measures wind speed and direction. Now, if the drone, as it balances itself out, it kind of moves in order to do that. And so whenever you're taking wind speed and direction measurements, it can affect all of the data that you're getting. So in order to kind of counteract having to mathematically post-process those movements out, we just went ahead and put a gimbal on it, so it just kind of auto-corrects.
And then moving down the line, we have the long guy, now we have the tall guy.
Yeah, so this one, who actually has some arms that are gonna come out like this.
Oh, that's fun.
He's pretty big. This is called an M600. This is another platform that you can get off the shelf, but it's really just made for modification. So we've been able to add a lot of sensors to it. You can add a lot of different payloads to it. And this is the big anemometer, the 3-dimensional anemometer. So both of these anemometers are actually ultrasonic. They use sound to tell how fast the wind is moving past them. They're kind of sending signals to each of the little sensors within them. And so that's how we're able to tell the wind speed and direction based on them.
I think we have one more drone behind you that we're bringing as well. Is that?
So this is a ground station. And so this is taking the same type of measurements as the vehicles, but this is just gonna be able to sit really, really close to the surface so that we'll be able to fly the profile and then be able to also just be getting static data as well. And it's kind of a benchmark for what we're seeing to make sure that we're able to kind of do a correlation between what's in the air and what's on the ground. It's a very traditional way of measuring things. And then it also allows us to see what that landscape looks like without the drone kind of kicking up dirt and stuff, so that we can make sure that the drone is getting really good data. In order to make sure that we're not getting too much vehicle noise, we're letting the anemometer sit and just kind of collect data, especially with the wind this low. We're just trying to make sure that we're actually able to get kind of those points along that profile.
USRI's research is part of a larger NASA effort focused on urban air technology and taxis.
This is going to help us understand how to move toward urban air mobility or advanced air mobility when you're wanting your air taxi to go around buildings or through an urban setting. You want to know exactly what that airflow is going to be doing. This is a first step to really understanding that in a real world scenario.
Companies are flying those and testing them right now, but they haven't yet been certified by the FAA. Practical implementation is somewhere between 5 to 10 years away.
If you or someone you know is interested in learning more about the Unmanned Systems Research Institute at Oklahoma State, visit seat.okstate.edu.